Only if you check the units only, then also you can estimate the answer, because the EMF, current, potential difference are only correct in this option. Now we will see the last problem in MCQ. The table describes the 4 different resistance wires. They are all made from the same metal. Which wire has the smallest resistance? So we had just seen the similar kind of problem. You can see here, if you want the smallest resistance in this case, we know the resistance is directly proportional to the length. So if you want the smaller amount of resistance, then the length should decrease, because resistance is directly proportional to the length. And here, if you want the decrease in the resistance, then area should increase, and if the area should increase, then you can say the diameter should increase, because R is inversely proportional to the area. So here the length and the diameter of the wire are given. So you can see here, this is a 2 meter wire is given, and diameter is nothing but 1 mm. So what we want, if you want the smallest resistance, then you can see the smallest amount of length and the highest amount of area, that is highest amount of highest value of the diameter we need. So what is that combination? You can see here, this is 2 2 and this is 3 3. So we want the smallest value of length, where it is a 2 and 2, and the among these two you can see the what is the higher value of the diameter, that is 1.5. So our answer should be option number B. Okay. If you want the smallest resistance, then smaller value of length and higher value of area, that is higher value of diameter. So option number B is only correct. This is among 4 you can see 2 can be the smallest. Among this 4 you can see 1.5 can be highest. So option number B is correct. Now we will see some structured questions. So you can read here question number 1. State what is meant by the direction of the electric field. So this question is about the electric field. We know that electric field is nothing but the field that directed from the positive to negative charge. Or we can write it in different language. Suppose this is the plate, you can see. These are the 2 plates given here. This is positively charged plate, this is negatively charged plate. So in between that, the space between that, we should have the electric field. And suppose if we have the positive charge over here, suppose if I have there is a small positive unit charge or any positive charges there. So which direction this charge will be moved? This charge will be moved toward the negative side of the plate. Okay, it will be moved toward the negative plate, because it is a positive charge. Okay, so we can say the direction of the electric field is nothing but direction of the force acting on this positive charge. Okay, because the electric field basically it is in this direction. It is from positive charge to negative charge, positive plate to negative plate, the positive side to negative side. So the force acting on this positive charge should be towards the negative charge. So we can write down the direction of the electric field in terms of the electric force. So we can write here, it is nothing but the direction of the force on the, let me say, positive charge. It can be the force on the positive charge, because the direction of the positive charge will be towards the, you can say, the negative charge, and the direction of the field is also from positive to negative charge. So we are going to explain that in terms of the force on the positive charge. So it is the direction of the force on the positive charge. Now the next sub question. In A, we have a second sub question is this. This figure shows a pair of the oppositely charged horizontal metal plates with the top plate positive. The electric field between the plate is uniform. This uniform word is very important over here. And draw the lines to represent the uniform field. Add arrows to these lines to show the direction of the field. So we know the electric field is the one which starts from the positive charge and ends at the negative charge. So we can I can draw this line over here. This can be my line. The what is important thing to remember, this line should be equally spaced. Okay, so the distance between the two lines should be equal. So here I am trying to draw the lines which are equally spaced. Why we want the equally spaced line? Because here you can see the field is nothing but uniform. So at least three lines you should draw in exam in order to show the electric field. And here the direction, you can see the direction is from positive to negative. So this arrow shows the direction of the electric field. Now we will see the next question, that is nothing but the question number B. So this figure shows a very small negatively charged oil drop in the air between the pair of oppositely charged horizontal metal plates. And the oil drop does not move up and down. So you can see the situation, this is negatively charged oil drop, and these are the plates which are charged. Okay, so one of them should be positive and one of them should be negative. So suggest in terms of the forces why the oil drop does not move up or down. Okay, it is not moving up or down. That means there is a balanced situation. That means it is like a tug of war. So in tug of war, the forces are acting in the opposite direction. When we have the equal and opposite forces acting on the object, we have a balanced situation, which we say the balanced force. So here we know on every object, this is the oil drop. So every object, the naturally the gravitational force, or you can say the weight, is acting, and that is always in the downward direction. So this force is a must over there because it is a natural force. So I'm writing down here. The weight is acting in the downward direction. This is a rough just writing. And if the weight is acting in a downward direction, there must be some force which should act in the upward direction. Then only we have this both the forces equal and opposite, and the situation is balanced. That means the oil drop should not move up and down. So there is some force which is acting in the upward direction due to the electric field. Okay, so this force should acting in the upward direction, and this oil drop is negatively charged. What does it mean? That means this upper plate should be the positively charged. Okay, then only it will be possible that that charge, this negatively charged oil drop, will move in the upward direction. So this is a positively charged plate. So obviously this bottom plate should be negatively charged. In this case, what will happen? The electric force which is acting on this oil drop due to the electric field should be acting in the upward direction, and that should be equal in magnitude to the weight. Okay, and weight is acting in the downward direction. So that way we can have the balance situation. All this is nothing but the rough drawing I have made over here just to indicate or to understand what is happening. So what are two forces acting on the object? Here I can write down the force. We have the force, can say force due to electric field, force due to electric field. Okay, or you can say the upward force because it is acting in upward direction. So I can write the force due to electric field in the upward direction is equal to the weight of the oil drop. Okay, because that is naturally acting in the downward direction, I can write down in the bracket. So this is the situation, and what does it mean? That means if both the forces are equal and opposite, that means the resultant force or the total force, you can say, the resultant force acting on the object is nothing but zero. So there is no force acting on the object because both are equal and opposite, so both will cancel each other. So this you can write down the answer in terms of the force. Now without losing any of its charge, okay, if the oil drop begins to evaporate, okay, state and explain what happens to the drop. So this is very important. We have to read the question very carefully. See, without losing any, can see this is without losing any charge. Only it is going to evaporate. So we know that two forces are acting on the object. The first one is nothing but the force which is electric force in the upward